Hello everyone, welcome back to the channel. This is the second video of the build of the Curtiss P-40E in 1 in 48 scale from Eduard. In the previous video I built a 3D printed cockpit. If you are interested and haven't seen this video, the link is on the screen and in the description below. This time I'm going to build a radio compartment. To me, this was the most joyful part of the entire build. So stay tuned and I will show you the whole process. This is a 3D printed upgrade set from Eduard designed for the P-40E model. If you are working on a P-40N model, there is a different set for the later version. The thin cardboard box contains 9 3D printed parts, a small PE sheet and an instruction manual. The parts are nice and clean, with no visible print layers on the surface. Only the big box on the starboard side needed a bit of cleaning, but it wasn't a big deal. Since Eduard uses better printers, the parts are much cleaner than before. I cleaned all the parts from the print supports. It was nice and easy, easier and quicker than the molded resin parts. Only a side cutter or a small pair of scissors is needed for this process. I used sanding sticks and sponges to smooth the edges and the parts were ready for paint and assembly. To prepare the surface I used a black primer. I used black primer because I wanted to use the black base as a pre-shading layer as well. For the interior color I used the same mix as I used in the cockpit, 80% of cockpit green and 20% of dark green. After the base paint had completely dried, I used a 0.3mm drill bit to prepare the holes for the control cables running inside the fuselage walls on both sides. Then I started painting the details with Vallejo and AK acrylics. These two paints are perfect for detail painting, as their drying time is not too quick. I painted the big box on the starboard side in silver after I quickly masked it. The bolts on the big silver box were dark grey. I mixed that grey on my wet palette. On the port side there was an oil reserve tank. Multiple tubes were running into the reservoir tank. I painted the pipes in copper. Unfortunately, I couldn't find a definitive parts list for the P-40E aircraft radio, or to be more specific, the communication system, and also I'm not an expert of this kind of equipment. I tried to make an overview of the communication system. If some of you have more specific knowledge about these vintage electronics, please share your info with us. The communication system components vary between operators and theaters. But here is what I found about the radios, antennas, power supply, battery or dynamotor that have been installed or likely installed on a typical P-40E or the RAF version on the Kitty Hawk. The radio system has 4 major components: the transmitter, the receiver, the power supply and the antenna. The 2 main parts of the radio are the transmitter and the receiver. The P-40E probably used the SCR-274N command radio set for both voice and Morse communications. Radios like the SCR-274N were modular and designed to be swapped in-out quickly for specific roles. The SCR-274N typically includes multiple receivers, such as the BC 453, 454 or 455. And 1 or 2 transmitters, the BC 457, 458 or 459. However, as I mentioned earlier, the components could have been different depending on the operational unit and or the theater. Eduard marked the control cables with different colors in the instructions. It was easy to cut them because the instructions included real life-size color-coded guides. All you have to do is place the wire next to it and cut. The cut size will perfectly fit into its place. Because I pre-drilled the holes for the cable, all I had to do was cut and place them into the guide holes. For the control cables I used Albion Alloy's 0.2mm nickel-silver rod. The P-40E often use long wire antennas. The wire strung from the fuselage to the tip of the fin and from the fin to each wingtip. The shift to VHF radio equipment in some P-40E variants sometimes meant replacing the wire system with mast-mounted antenna, thereby eliminating the long wires. The SER-274N and related radio modules required high-voltage DC power. Typically, the aircraft power source was 28-volt DC. The dynamotor unit, such as the DM32 or the DM33, provided the necessary high voltage from the aircraft electrical system to the radio valves. Normally converts the 28-volt DC input voltage to an output voltage of approximately 250-volt DC. The exact output current may vary depending on the module, but it's generally intended for low-power receivers. The dynamotor is essentially a single housing motor generator set that combines an electric motor and an electric generator on the same shaft with two separate armature windings. It takes electrical power in one form, such as low-voltage direct current, and converts it to high-voltage direct current to power the vacuum tubes of the radio receivers. I don't know what exactly was in the big silver box, probably some switchboard for the radio unit, but the large clean surface almost cried out for a bit of improvement. I thought that I could make the blank, empty surface much more interesting by adding instructional inscriptions on it. But first, there was some instrument on the top left corner. I don't know what it was, but I used an extra instrument decal from the cockpit set. I cut it around, and as usual, I applied a drop of Mr. Mark Setter first. Red is always a good choice for text. I rummaged through the box full of leftover decals from previous projects. I always keep all of the leftover decals. If I remember correctly, the red inscription was left over from a Mustang kit. The black is again from the cockpit upgrade set. I also wanted to make something that stands out from the clean surface of the silver box. So I made a little lock sheet in the plastic pocket. I can't remember where the idea is coming from, but here's how I made it. I used the transparent film from the cockpit upgrade set and cut out one of the A templates. This time I cut next to the black line, so I ended up with the line around. On the side of the tweezers, I bent the film slightly to form a pocket shape. The protective paper on the decals were perfect for the lock sheet. I painted it pale yellow and added some writing on it. I glued them on the box with Tamiya clear. First I applied the clear to the bottom, then to the corners. I had a feeling that it was too much. I made the box too busy, but I just left it as it was. What do you think? Are these extra details too much? Would it be better without? Or is it fine? Let me know your thoughts in the comment section. Nowadays a modern aviation radio can fit in our hand, but back in those days the radios used vacuum tubes, and these vacuum tube driven radio devices were large and heavy pieces. For the detail painting I use Vallejo and AK acrylics. I dropped a bit of paint on my wet palette, and these paints can be used for a long time. I use the dry brush technique to highlight the edges. Obviously, these highlights are just for creating an optical illusion of shapes, tones and depth. For weathering, I used highly diluted mixture of Tamiya dark brown panel liner and various oil paints. I don't like over-weathering my models. All I want to create a tone variation to make optical illusions. During World War II, aircraft used multiple transmitters and receivers for several critical reasons. There were technological limitations of the time and operational requirements during wartime. Radio technology wasn't as sophisticated and miniaturized as it is nowadays. These units were single-frequency radios, meaning the radios could only operate on one frequency or a narrow band at a time. Changing frequencies meant physically switching inbuilt electronical components, which was time-consuming, and it was impossible during combat. Each transmitter or receiver was optimized for a specific frequency band depending on the operational unit used. Multiple units were needed to cover different frequency bands. Different missions required communication with other entities, often simultaneously, like air-to-ground, contact with base or HQ, air-to-air, communication with other aircraft, navigation aids, receive signals from beacons, and an intercom system for crew communication within the aircraft. Obviously, the intercom wasn't used in the single-seat aircraft. Redundancy is very important in aviation. Radios were prone to failure due to vibration or vacuum tube burnout. Having more than one radio increased survivability and mission success. Also, jamming and interference could be a serious problem. If one frequency or radio was jammed or had poor propagation, other might still function. There was only one place where I had to install a wire. I used 0.5mm LED wire. I like to use LED wires over copper because LED wires are easy to shape and paint. I tend to bend the desired shape in advance, then attach one end with superglue. After the glue has completely dried, I fine shape the wire into the desired position with tweezers. Then glue the other end in place. This upgrade set was a lot of fun. I know most of the fine details will be hidden deep inside the fuselage forever, but it was still a lot of fun to build. For me, it was probably the most enjoyable part of the entire P-40E project. If you like details and don't mind your work being hidden forever, I definitely recommend this radio set. In the following video, I will go back to the cockpit build. There was still a lot of work on the cockpit before I could build it and the radio compartment into the fuselage. So stay tuned because a very interesting video is coming. If you enjoyed watching this video and are interested in the upcoming ones, please hit the like and consider subscribing to my channel if you haven't already done so. If you click the little bell, you will receive notifications of the new videos on my channel. Your support means a lot to me. It keeps my motivation high. Also, please feel free to share your thoughts or questions in the comment section. Thank you for watching, keep modeling, and see you next time.